This is the final lesson for Chapter 3, and what it's going to do is it relies on the concepts learned in 3.6 when you have compound inequalities. And this is basically going to be absolute value inequalities, just like in Chapter 2, we had absolute value equations at the end. So I'm going to split this up into two parts. So we're going to start with the first one, less thans. Okay, now this is really important, so here's what I want you to write down. Because basically the way to tell them apart is by the inequality. So what you're going to do is you're going to write down less than are and inequalities, and then highlight it. Yes, highlight it. Less thans are ands. So if you have an absolute value equation and the inequality is less than, you treat it like an and compound inequality. Remember the 3.6 video, we talked about ands and ors and how they were different. If you don't remember that, or if you're having issues, I'm putting all these videos online. Make sure you're checking them, rewatch them, do what you need to do. So let's go ahead and actually solve one of these. Okay, we're going to do both examples, so you can call this as the less than example, and we have A and B. So this is an absolute value inequality. Now, if you remember in Chapter 2, we had to split up the absolute value, right? But before we could do that, we had to move anything that was next to it or multiplying it. In this case, it's that 3. So we have to move it. So we're going to minus 3 from both sides. 12 minus 3 is 9. So now we get the absolute value of x is less than 9. Now, if this was an equation from Chapter 2, we could just automatically go x would be 9, x would be negative 9, and remember we could write our answer like this. We can't do that here. It's an inequality. It is a less than. So I'm still going to split it up, but watch what I do. Remember, the first one you can make your positive, so x less than 9. But remember, when we do our second equation, we have to make this negative. Now let's think for a minute. We're dealing with inequalities. If I change the sign on something, what else do you think I have to change? I have to change my inequality. So when you change your value here for the negative, you flip your inequality. When you're just writing it as is, positive, you do not change it. So, how do we write our final answer? Let me move all this over here, this little guy. So it's an and, right? Remember, with ands, x goes in the middle. And in this case, we have just less thans. They're not less than or equal to. We put the less thans around it on both sides. Now, this is the lower bound. This is the lowest x can go. This is the highest, or the upper bound, highest x can go. So now this says x must be less than 9. That means the highest it can go is 9, so that goes here. This says x must be bigger or greater than negative 9. That means if it's bigger than that, that means it's the lowest it can go. So there's our answer, and then of course we do our graph. Lower bound, upper bound. In this case, they are both open circles. Just like that. Okay, so hopefully you're seeing your Chapter 2 skills right here, specifically 2.7. So really quickly, all I did was move the 3 over because it was outside the absolute value, and I need to isolate the absolute value. Once the absolute value is isolated, I split it up into a positive, so nothing changes, and then when I change this to negative, I flip the inequality. At this point, I don't have to do any more work, so I can write my answer. Since it's a less than, it's and, x goes in the middle. My lower bound was negative 9 because x must be bigger than that. My upper bound is positive 9 because x must be less than that. There it is. So let's do the other one. Now if you notice here, I don't have to move anything. Like I did over here, I had to move the 3, right? So since I don't have to move anything, I can go right into the beginning of just splitting it up. So we have the positive. Notice nothing changed. All I did was drop the absolute value. And then the negative. Notice I made the 2 negative. You never, never, never change the sign on the inside. Now since I made the 2 negative, my inequality must flip. I now have 2 single-step equations, so we can solve these. Those are easy. So over here I get x less than or equal to -2. Over here I get -6, so I get x greater than or equal to -6. So this is an and. How do I know? Because it's a less than. So because of space, I'm just going to put my answer over here. So x goes in the middle. This is my less than. I put both of those just like that. Now, what's my lower bound? What's the lowest x can go? Well, x must be bigger, greater than or equal to -6. So that means that's the lowest it can go. But x must be less than or equal to -2. That means that's the highest it can go. So, here's my answer. And then let's do the graph. And these, in this case, are both closed circles, because the inequality is equal to. So there you go. Okay? Alright, so now it's your turn. Just pick one. Go ahead and pause the video. Alright, now that you've had a chance to try it, I'm going to do both because you had a choice. So on the first one here, I'm going to divide by 2 on both sides. Why? Because 2 is multiplying the absolute value. Now notice I'm dividing by a positive, so I do not flip this absolute value. So I get x, absolute value of x is less than or equal to 3. Now the absolute value is isolated, I can split it up. Positive, negative. Again, I flipped my inequality because I made 3 negative. Now, these are done. So since it's an and, x goes in the middle. Let's see my lower bound, x greater than or equal to -3. My upper bound, x is less than 3. And then for my graph, I have closed circles in the middle. Over here, I'm going to actually leave the decimal alone because I can see that they both end in 0.5, which means they're going to add easily. Here I have to add this 4.5 to the other side. And I get 12. So now I have the absolute value of x plus 3 less than or equal to 12. So now that my absolute value is isolated, I'm going to split it up. I have my positive, and I have my negative. Notice when I made this negative, I did not change the inside. You never do that. And then all I did was flip my inequality because I made 12 negative. Now these are both single-step equations. It's an and, so x goes in the middle. In this case, it's less than or equal to, so I got to put equal to's on these. So this is x less than or equal to 12, x greater than or equal to -15. So this is my lower bound. This is my upper bound. And then I'll put my graph up here. And in this case, again, they're both closed circles, because my absolute or my inequality was equal to. Okay, so these are less thans. Hopefully you got yours right. And they're all less than, so that means we treat them as ands. So let's move on. So if it's not a less than, it's a greater than. So in your notes, greater thans are ors. See how it's kind of like greater than? You kind of exaggerate the word greater, and it has kind of the word or in it. Like just like if you say less than, it kind of has and in it. So greater than are ors, less thans are ands. So write this down and highlight it. The problems are not going to tell you if it's an and or an or. It's just going to give you a problem, and you have to look at the inequality and decide, is this an and or it's an or? All right. Okay, here's our greater than example. So we're going to do both. Okay. In this problem here, again, our goal is to isolate the absolute value. We're going to plus 20 to the other side. So here I get 7. So now I get the absolute value of x greater than 7. So we're still going to split it up because now my absolute value is isolated. Again, we have one positive, and then we have that negative, so we still flip the inequality. And notice these are basically done. Now this says, since it's an or, we put or in the middle. This says x must be greater than 7 or x must be less than negative 7. Okay? Now I don't really matter which one comes first. I don't mind. So now, this is our lower bound, right? Because x is less than negative 7. So that means negative 7 goes over here. This is the upper, because it's greater than. So I have open circle and negative 7 to the left because it's less than. And in this case, I have open circle on 7 to the right because it's greater than. And that's it. Okay, so notice the steps are still the same. The only thing that changes is when you go to write your answer. And the reason we knew it was an or is because the inequality was a greater than. Okay, let's do the next one. Alright, so over here, we have to move the 5. So we're going to minus 5. So we want to isolate this before we split it up. So now we have the absolute value of x minus 8 greater than or equal to 6. Now it's isolated, so let's split it up. Here's the positive, and here's the negative. So these are both single-step equations. So I get x greater than or equal to 14. And I get x less than or equal to 2. So, our answer, I'm going to put it over here because of space. So x must be greater than or equal to 14, or x must be less than or equal to 2. So let's do our graph. Alright. Well, 2 has to go down here, 14 has to go down here, or over here if you think of a number line. So now, let's do our shading. X is greater than or equal to 14, and it's a solid circle to the right because it's greater than. X is less than or equal to 2, so again, solid circle because it's equal to, but since it's less than, it goes left. Okay? So, this is basically it. Greater thans are ors, less thans are ands. So, go ahead and try. Pick one, please, and go ahead and pause the video. Okay, now that you've had a chance, let's see how you did. Remember, I only flipped this because I made the 2 negative. I'm going to put my graph up here. Close circle to the right, close circle to the left. Okay? Alright, now, I'm sure most of you avoided this one, that's okay. Since I see this right here, what I think I'm going to do is I have a half over here. I think I'm going to leave it as a fraction because I know eventually I'm going to have to add the halves together and subtract them, and since the denominators are the same, it'll make it easier. So what's 4 wholes minus a half? That gives us 3 1/2. So really I have x plus 2 1/2 greater than or equal to 3 1/2. Now if the denominators didn't match, then I would clear the fractions. So we have our first one. X plus 2 1/2 is greater than or equal to 3 1/2. And then we have the negative one, excuse me. X plus 2 1/2 less than or equal to negative 3 1/2. Okay, so I'm going to minus 2 1/2. Minus 2 1/2, that gives me 1 whole. Over here I'm going to minus 2 1/2. Minus 2 1/2, and this actually gives me negative 6. So I'm going to put my answer up here and then I'll put my graph up there. So really what I have is x greater than or equal to 1 whole, or x less than or equal to negative 6. So now for my graph, negative 6 will be on the left, positive 1 will be on the right. Now it says x must be greater than or equal to 1, so that's closed circle to the right. X is less than or equal to negative 6, closed circle to the left. Okay. So hopefully you did well. If you didn't, hopefully you can see what your mistakes were. So that's it for the first part. You're just doing ands and ors. In my second part of the video, that I'll do at a later time, we're going to do word problems and special cases.